Welcome to Lesson 5 in Ratios and Proportional Relationships. Again, we're still on Module 1. Today we are going to talk about something a little bit different, identifying proportional and non-proportional relationships in graphs. Okay, so being able to, I guess what we want to get to eventually is to actually be able to look at a graph and be able to tell by the way it looks that there is indeed a proportional relationship at work. Okay, and let's open up with this this opening exercise here. Isaiah sold candy bars to help raise money for his scouting troop. The table shows the amount of candy he sold to the amount of money he received. Is the amount of candy bars sold proportional to the money Isaiah received? And how do you know? And again, that's that question. Boy, you guys probably, maybe some of you are getting real tired of it, but you know, it is really, really important that we continue to look at it. Now, if we go ahead and you can just see down here, see the table that's been written for you. Candy bar sold to money received. If you went ahead and just made some ratios out of those, that would be this one here would be 2 to 3. This one would be 4 to 5. This one would be 8 to 9. And at the bottom, 12 to 12. Okay? So you can see right away that it is not indeed proportional. The candy bars sold and the money received are not proportional because you can see those ratios change as we go down the table. Okay? Yeah, so right here you can see candy bars sold 2 and you received $3. Now you can tell in this case that a candy bar is more than $1 each, but when you sold 12 and for $12 they were $1 each here, so you can see that the per unit price has actually changed. And in this case it's a pretty realistic case. Okay, again, it's not proportional, but it is a realistic case in that we do very often have volume discounts in life. When you buy things at the supermarket or elsewhere, buying in bulk or buying more generally will cost you less per unit. Of course, not less total, because 12 here is more than 3, but the per unit price has changed. It's gone down. Okay, but anyway, yeah. So no, there's no proportional relationship here. Okay. But we can make these numbers proportional. Right here, let's look at this example 1, and right here we want to go from a table to a graph. Okay, so if we went ahead and made this this table proportional, the next number of candy bars sold here we had was 4. Okay, was 4 here. All right. Now, if the number of candy bars sold was 4, and here we had a ratio of 2 to 3, 4 to what number would be equivalent or would be proportional to 2 to 3? And hopefully we're getting this now, because we know when we go from 2 to 4, that is times 2. So we would do the same for the other side. So 3 times 2 would be 6. So we would get $6. And again, if we did 8, we would therefore have 12. Again, the same proportion. And then 12, we would have 16. Okay, so in each case, we are looking at, so not 16 there, that would be 6 would be 18. Yeah, back there, 18. Okay. Yeah, so all of these ratios here, 4 to 6, 8 to 12, 12 to 18, they are all equal to 2 to 3. Okay, so you can see in the end these are all equal, and this is the simplest form for this ratio would be 2 to 3. Okay, but here we go. So we filled out our table. And now with this table, we want to go ahead and make a graph. Now this little graph is little teeny tiny over here on this page here and on your page as well. So I'm going to go to something a little bit bigger and just work with that there. Okay, this one here. Hopefully I have enough squares here. Well, we'll just do it. Well, we'll just talk about the parts of a coordinate plane. Okay, so if we look at a coordinate plane, and we'll look at it this way here. That, of course, is our y-axis. Here is our x-axis. Okay, usually are always labeled. Okay, with x and y. Now there are a couple of points I would like to talk about. One of them is a very, very important point is the origin. Now, if you know where the origin is, you can point to it now, but I can't see you. Anyway, the origin is right there. Okay, and the origin, and again, you guys have done this type of thing in 5th and 6th grade, or hopefully you have, and if you have, it's probably very familiar to you. But that origin is where x and y both equal 0. Okay, x and y both equal 0. Now a coordinate plane has different quadrants, and this happens to be quadrant 1 over here. Okay, this quadrant 1. And quadrant 1, we're going to be working here, and the reason we're working in quadrant 1 is that we're working with all positive numbers. Okay, so everything here is positive, all positive values. Okay, in quadrant 1, it's the only one that has that. So it's positive, positive, and in this case here we have a positive x, we have a negative y. Over here we have both are negative. Okay, and here we have a negative x and a positive y. So we're going to work in quadrant 1. Okay. Now, if we were going to go ahead and label, let's go ahead and since we're going to work in quadrant 1, we don't really need all of this. Let me just go ahead and just erase all of this here. Let's go ahead and make our coordinate plane look a little bit different, where we only show, and this is basically what we're going to be doing a good part of this year, is we're only going to be working with quadrant 1. So we went ahead and made quadrant 1 like this. Okay, we need to label these axes, and again, we know as a letter this is y and this is x, but they also need to have some sort of label, so people know exactly what we're talking about. Now the x-axis, we would like to label chocolate bars. Okay, so we could do chocolate bars. Now again, the chocolate bars, this x-axis is usually what we call the independent variable. Okay, independent, it's the one that we change. Okay, so we're going to change the numbers of chocolate bars we sell, and then we're going to get the y-axis. This is a dependent variable, and we're going to call this one the money. Let's just put dollars received. Okay, dollars received. Alrighty. So again, independent here, independent, and then dependent on the y. Okay, going up that way. And again, you remember that this point right here is 0, 0, where there are nothing sold. Okay, so if we go ahead and plug in some of these numbers, this may not be big enough for me to plug them all in, but if we do go ahead, we can plug in our first pair, and that's where x equals 2 candy bars. Okay, so we go right here. This is x equals 2, and then the y equals 3. 1, 2, 3. Okay, so right there, that is 2, 3. Okay, 2 candy bars, 2 chocolate bars, and then $3 received. All right, and the next is 4. 2, 3, 4. Okay, so 4, and then 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 right here. Okay, so that is 4 and 6. And I think I've run out there. Anyway, let's do it again. What do we have? Then we had 8 and 12. So 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, way up here. But anyway, by doing this, and if we plot, it's always good to have a third point plotted, okay? And there are other ways we could do that. What's going to happen eventually, we are going to draw a line that connects all of these points. And again, if you're doing it on your other one, we could actually try to do it on the smaller one here. I'm going to increase the size here, but I can't even see this thing on my page. So I'm going to go back to where we were here. Okay, so this one here we have. So if I do indeed do it, and you need to trust me here, okay. And again, you could do this yourself too. Again, if I had a ruler, that'd be super duper. Okay. Now, when I do plot and I connect all those points, I notice that the line passes through the point 0, 0. 0, 0, okay, that origin. And that is one of our keys to knowing that our relationship is proportional. Okay, so where we sell 0 candy bars, we get $0. Okay, and then from there. Okay, so here's some questions I want to ask you. So, what do you notice about the arrangement of the points? Again, hopefully you're doing this on some smaller grid paper. You know, I have some grid paper, so actually some books of graph paper I need to get to you, and I will do that coming Monday. You will notice that they all fall. Hopefully you see they fall in a straight line. Okay, and again, please, I didn't do that here because I'm afraid of messing this thing up since I'm doing this on my iPad. But if you do use a ruler all the time that you're working with graphs, much appreciated. For me, for your parent-teacher, and also for yourself. So if we extend the line in both directions, we really couldn't go past 0, 0 because you don't sell negative candy bars. Well, we're not going to work with negative numbers at this point. Okay, so I just changed my graph. I got some smaller squares here. Again, a little bit easier to see. I've plotted all of my points. I had 2, 3, 4, 6. Again, all the same ratio. 8, 12, and then 12, 18. Now, honestly, if you looked at this. Well, technically, actually, I put this is an arrow right here, you always put, because that just, suggests infinity, that this line would continue on and on and on. And it would, because with this proportional relationship here of what we have is like $1.50 per candy bar, this would continue in this straight line, okay, straight line for forever and ever, okay. Again, another thing to look at is that if you remember in the past, different proportional relationships, for example, if a worker worked 0 hours, he or she would get $0. Okay, those are proportional relationships. Remember back when we had a case of somebody making, was it $8 an hour for mowing the lawn or whatever they were doing, forgot. But yeah, so this graph, and again, this is a very important point, and I want to actually, you have a page, I think you have a page on there that talks to this. Let's go and take a look at that. That is down here, this important note right here. So this important note. So if you were to go ahead and write this in your important note, okay, in a proportional relationship, and you're going to write that right in this box right here. In a proportional relationship, in a proportional relationship, the points will all fall on a straight line and go through the origin, which again is 0, 0. Okay? Okay, so here we are. We have another few examples here. Example 2, example 3. For example 2, I want you to take a look at it and tell me, do they represent quantities that are proportional to each other? This is example 2. Okay. All right, and if you look, we look and we have 2 to 3. Looking real familiar, huh? Oop, 4 to 6 is the same as 2 to 3. Those are equivalent and therefore proportional. Ooh, 8 to 12. Yep. 12 to 14. No, this is the one that ruins it all. Everything was fine and dandy until this came along. Okay? Because, what can we lower that to? We can lower that to, we can divide that by 2. We get, what, 6 to 7. Okay, which is definitely different than 2 to 3. Okay? How about the graph of this ratio table? What can you predict about about the graph? Do you think these points will lie on a straight line and go through the origin? Well, we can go ahead and try it if you would like to. I'd like you to go ahead and turn this off, pause, and go ahead and take a look, and let's see if it does indeed work to fall in a straight line and go through the origin. Okay? All right, so pause a little bit and come on back. Okay, if you did go ahead and graph those numbers from that table, you will notice that something's not right. Yes, indeed, it's not a straight line. As you can see, it does a little curvy-wurvy right there because the ratios have changed. Okay, remember we said this was 6 to 7, whereas all of these here were 2 to 3. All of these. Okay, so yeah, the ratio changed. When that ratio changed, right there, the graph took a turn. So remember, with our important points, and one of those important points was that, and let's go back to that. Our important points was that one of the line had to be straight. Okay, a straight line, which went through the origin. Now, while we do have the origin, we do have it going through the origin. We don't have it as a straight line. So it has to meet both of those criteria. Okay, so let's go ahead and go back to this example 3. And here, example 3, you have some more data. Okay, some more data there. So if you would go ahead and take a look at that one and graph it, if you haven't already. And I'm going to pause, and you guys can come back and take. So now, if you notice, with example 3, that's this one here with the green points right over here. This one. This was example number 3. And this was the line for example number 2. In number 2, we noticed that while it did go through the point of origin right there, 0, 0, it did not move in a straight line. Now, example 3 does indeed have a nice straight slope to it here, a nice straight line. But as you can see, it does not go through the origin. Actually, it crosses the y axis at the number 6, 0, 6 right there. Okay. Now, in terms of the graphs, they have some similarities. Okay, all the points lie on a line. Okay, one is steeper than the other, and you can see that the graph number 2 moves a little more steeply and then curves. Okay, but the ratios, the quantities are not proportional to each other. Okay, you can see in both of them where you have we did these already, and we realized that these were all 2 to 3, whereas this one here was at 6 to 7. The ratio of those. Over here now we have 0 to 6. First of all, that just really throws you off with the 0 6. And then 3 to 9 is the same as 1 to 3 right there. And then we have, actually this one is 1 to 2. So these are all over the place. Okay, that example number 3 is all over the place. Okay, so the ratios. Okay, so all of these, the similarities of the graphs of the two quantities, they both have points that lie in lines again, but the graph of the quantities that are proportional to each other must also go through the origin. Okay, so we have problems with 2 and problems with 3. Okay, so neither one of these is a graph of a proportional relationship. Okay, so in summary, you can see you have a lesson summary there on the next page. When two proportional quantities are graphed on a coordinate plane, the points lie on a straight line, and that line passes through the origin. Okay, so points lie on a straight line, and that line passes through the origin. Has to be both. Cannot be one or the other. It has to be both for a graph to represent proportional quantities. Okay, so if we go ahead and again look at the graph that we made, two graphs. I have two graphs on one coordinate plane here. But again, don't be fooled, because some kids will make the mistake. Oh yeah, this went through the origin right here. So remember 2, example 2 went through the origin, but it also did this little thing up here. Okay, it curved. Okay, it was straight for a while, then curved. That makes it not proportional. And the problem with number 3 was that you see it was a nice straight line, but it did not pass through the origin. So both of these graphs, they represented two different problems with the graphs. Okay, so here you go. Here's your problem set. Go ahead and complete that, and then continue on, do your exit ticket. And if there are any questions, please, you could always email me, and look forward to the next lesson 5 or 6.